Hi everyone, welcome to the class. A very good evening. Right. So today we are going to continue our discussion from yesterday's class. So I'm taking a series of classes on Fourier transform, and yesterday I've taken the first class where I've explained the very basics of Fourier transform, why Fourier transform, what is Fourier transform, and what do we get, what is understanding the formula for Fourier transform. So all that we have understood in the yesterday's class. So in today's class, we're gonna understand few more things about Fourier transform. So we're going to do some problems based on the very basic formula of Fourier transform. Really interesting questions and very important questions we're going to solve today. Right. So let us start. So if you have not gone through yesterday's class, you can go through. In YouTube, you can just search with my name. You'll be getting all the classes that I've taken. So you can go through Fourier Transform Basics Part 1. So if you have not gone through it, that is fine. So yesterday, this is what we have discussed. These are the topics that we have discussed. These are all the things that we have discussed in yesterday's class. Okay, right. So if you have not attended yesterday's class also, that is fine. You will be able to attend it. You will be able to understand today's class. No problem. Right. But yesterday I have given you a very good understanding of all the things, like what is frequency, what information does Fourier transform give us. A lot of very basic stuff I have discussed in yesterday's class. Right. So today's class, you can understand it without understanding yesterday's class also. Without attending yesterday's class also, you'll be able to understand. Okay. Fine. So let us start. So first let me write the Fourier transform formula. Fourier transform of a signal x of t. Generally Fourier transform is denoted by the letter f of, we can write, or sometimes people write it as ft of. People also write it as ft of also. Notation, any notation is fine as long as we are understanding. Notation is not really important. So, and one more notation for Fourier transform is capital X, whatever small letter we are using in time domain. Generally we use small letter in time domain, but using capital letter in time domain is not wrong. Okay, but preferably we use a small letter for time domain signal representation, and for the corresponding Fourier transform or corresponding frequency domain representation of the signal, we use capital letter. So it can be capital X of omega. So this is the Fourier transform. So X of omega, or we can also write as X of f also. Both are same. Both are exactly same. X of omega, X of f, both are correct. Both are exactly same. So if you replace omega with 2 pi f, you can ask me, sir, if I replace omega with 2 pi f, it will become X of 2 pi f. No. Yes, correct. It becomes X of 2 pi f. But when you're saying a function of x, if something is a function of, suppose I'll give you a function. If I say it is 2x whole square plus 4, so is it a function of x or not? Since it is a function of x, it is good to write it as f of x. What is the underlying random variable? That is what, whatever is the underlying variable, that is what we are going to write the function of the variable, right? So if you replace omega with 2 pi f, what happens? The 2 pi is just a constant, right? So since 2 pi is a constant, f is the only variable. If you replace omega with 2 pi f, f is the variable. So that's why instead of writing x of 2 pi f, we simply write it as simply capital X of f. So x of omega, capital X of f, both are exactly same. If you know the Fourier transform in terms of omega, just replace it with 2 pi f, you will get the Fourier transform in terms of f. So whenever somebody talks about Fourier transform, you can represent in terms of omega, or you can represent it in terms of f also. Okay, but generally, whatever formulas we remember, they are in terms of omega, generally. But there is no rule that the options should be given only in terms of omega. What we remember, generally we remember in terms of omega. But in the options, you might be seeing options in terms of f also. If you see that, whatever answer you get in terms of omega, take that. Replace omega with 2 pi f, then you are going to get the answer in terms of f. Okay, simple conversion. Okay, as we go through the multiple problems, I'll tell you how to convert the answer Fourier transform from omega to f or f to omega. Okay, right. So first let me write the formula for this. X of omega, the Fourier transform of the signal x of t is given as integration of x of t into e power minus j omega t. Hi Umesh. If there is any doubts, you can just let me know. Right. This is the formula for Fourier transform. Yesterday I have explained a little bit about what we are getting out of this formula. Okay. So what we're getting this formula is, from this formula is, we're trying to find the component of x of t on e power j omega t. Which means we're trying to find how much magnitude of omega frequency is present in x of t signal. X of omega, we call it as Fourier transform or frequency domain representation of the signal x of t. For the whatever information is there in x of t, same information is there in x of omega also, but it is a different dimension of representation. It's a different, x of omega is different way of representing the same signal x of t. Okay, x of t and x of omega, they are representing exactly same information, not at all different. Okay, right. This is the Fourier transform formula. So now let me write the inverse Fourier transform formula also. So inverse Fourier transform formula is x of t is equal to 1 by 2 pi into integration capital X of omega into e power plus j omega t d omega. Limits from minus infinity to plus infinity. So this is the inverse Fourier transform formula. The formulas are very similar. If you know the Fourier transform, multiply with e power j omega t. In the Fourier transform formula, you are multiplying with e power minus j omega t. Here we are multiplying with e power j omega t. Okay, a slight difference. Okay, it's easy to remember this difference. Okay, and then integration. So here, when you're trying to convert the signal, time domain signal to frequency domain, what you're doing integration with respect to time, and after integration, you're substituting time with infinity and minus infinity, right? So it means time will vanish. So if time variable vanishes, then what happens? It will be a function of only omega, right? Only omega remains after integration. So that's why it will be a function of omega. Since you want it to be a function of omega, you're integrating with respect to time. Whereas, if you're talking about inverse Fourier transform, since the inverse Fourier transform of x of omega should be x of t, which means it should be a function of time. So that's why you should not integrate with respect to t, because if you integrate with respect to t, if it is dt here, t will vanish. It will not be a function of time. So that's why there are two variables here, omega and t. So if you integrate with respect to omega, after integration, omega is substituted with infinity and minus infinity, and what happens? Omega will be vanishing because omega is replaced with infinity and minus infinity. So if omega vanishes, what is the remaining variable? Only t is the remaining variable. So after integration and after substituting the limits, this will be a function of only time. So you have to observe the variable of integration here. The variable of integration in Fourier transform formula is t, and the variable of integration in frequency in inverse Fourier transform formula is omega. Okay. So let me write one more variant of this inverse Fourier transform formula, and that is replace omega with 2 pi f. If you replace omega with 2 pi f, as I told you, x of omega, if you replace omega with 2 pi f, it will be x of f only now. As I told you, it's not, means it is better to write it as x of f, x of omega. Yes, there is nothing wrong in writing it as x of 2 pi f, but since the variable is f, we can also write it as x of f. Omega replaced with 2 pi f, so we can simply call it as x of f. Just replace omega with 2 pi f everywhere. So here also replace omega with 2 pi f into t into d omega can be written as d of 2 pi f and 1 by 2 pi. See this one? D of 2 pi f means, can we write it as 2 pi into df? Can we cancel this 2 pi and 2 pi? See this one? So if you cancel this 2 pi, what happens? It becomes df and 2 pi also will vanish. So I'm just rubbing it. So I hope you are understanding what is happening here. If you're trying to write the inverse Fourier transform formula in terms of using f as the variable, then what happens is it changes to this formula. Small change. Instead of d omega, df. Omega replaced with 2 pi f, it is becoming d of 2 pi f. D of 2 pi f is 2 pi into df. D of 2 pi f is 2 pi into df, that 2 pi and this 2 pi gets cancelled. 1 by 2 pi will be vanishing here in this formula. So x of t formula, inverse Fourier transform formula, we can write it in two ways. One using variable as omega, integration with respect to omega. Another formula is integration with respect to f. Both are not different formulas, they are same formulas only, but we are changing the frequency variable here. F is also frequency, omega is also frequency. Okay, whenever you are talking about Fourier transform, you can represent it in terms of omega or you can represent it in terms of f. Whatever answer you got here, if you replace omega with 2 pi f, then whatever you can represent it as x of f also. Okay, right. So Fourier transform formula, only single formula. Okay, only single formula here. Whether you write it as omega or whether you write it as 2 pi f, in both cases it's the single formula, no changes. Okay, whereas inverse Fourier transform formula, with a small change, there are two different formulas with slight changes based on which variable you are using, f you are using or omega you are using. Based on that, two different formulas with slight changes. Okay, fine. So these are the wonderful formulas that we have. Now let us play around with these formulas. Let us see what kind of questions can be asked from using based on these formulas. So beautiful observations can be made out of these formulas. Let us make those observations as we go further. If there is any doubt, just let me know. Fine, wonderful. Now let me make the observations. Simple observations, but very interesting observations. Right. In this formula, I'm putting f equal to 0 or omega equal to 0. I'm putting f equal to 0 or omega equal to 0. Both are same, no? If you put f equal to 0, omega is also 0, right? Because omega equal to 2 pi f. Now what happens on the other side, right hand side, what is happening? If you put omega equal to 0 here, on the right hand side also, wherever omega is there, replace it with 0. Replace omega with 0, what happens? Integration of x of t into e power j 0 into t is e power 0, which is 1. Right? So this part becomes 1 when you put omega with 0. Simple. See, a beautiful observation we got here. Beautiful observation we got here. And the observation is, in the Fourier transform, if you are trying to understand the value at 0 or the magnitude, what is this value? What is this? This is magnitude of 0 frequency. It is magnitude of 0 frequency. F equal to 0. Okay. So the meaning of x of f equal to 0 or x of omega equal to 0 is the magnitude of f equal to 0 frequency. F equal to 0 corresponds to DC only, no? F equal to 0 corresponds to DC only, right? So it gives us, x of f equal to 0 gives us an idea of how much of DC is present in the signal. And how do we find that? In time domain, if you find the area of the signal x of t, this is nothing but area of the signal, right? Area of the signal x of t. If you find the area in time domain, it is same as the value in the frequency domain at f equal to 0. Area in one domain is equal to value at 0 in the frequency domain. Beautiful observation, right? So a lot of questions can be framed based on the simple basic. So how simple is this basic? You have observed, right? So simply we got it from the formula, but this basic can be used in 100 different problems. Such a beautiful observation this is. Right? I'll show you as we go further. I'll show you how many places we can use this basic and how many different problems we can understand using this. Right? Let us make one more observation based on the other formulas, the inverse Fourier transform formula. In the inverse Fourier transform formula, variable is t. Now let us do the same thing here also. Earlier what we have done, f is the variable, we have replaced f with 0. In the inverse Fourier transform formula also, replace t with 0. Replace t with 0. So what happens on the other side? It is 1 by 2 pi integration x of omega, limits from minus infinity to plus infinity. So this one, wherever t is there, replace it with 0. Replace it with 0 because on the left hand side we have replaced t with 0. On the right hand side also, wherever t is there, replace it with 0. What happens now? It becomes e power 0. E power 0 is 1. Right? So it becomes simply d omega, right? And how about the second formula? How about the second formula? It is, in the second formula also, if you replace t with 0, e power 0 becomes 1. So the formula turns out to be, the formula changes out to be like this. Integration of x of f df. See this one? Let us understand the meaning of this. Here magnitude of x of f at f equal to 0. And here value or I can also say it as magnitude also. We can also call it as magnitude of x of t or value of x of t. Value of the signal x of t at t equal to 0. The value of the signal at time t equal to 0. In time domain, the value of the signal at t equal to 0 is same as area of x of omega, area in frequency domain, divided by 2 pi extra. Whenever you are dealing with omega, generally there will be a 2 pi factor. Okay, so we will be observing this 2 pi factor in a lot of other properties that we are going to discuss in future. Okay, and whenever you are dealing with f, that 2 pi factor will be missing. Area of x of f. See this one, it's easy to remember in terms of f, right? Whenever we are dealing with omega, there might be a factor of 2 pi. Okay, yeah. So observe these two properties, a very simple relation. If you find the area in time domain, that is same as the value at 0 in frequency domain. The value at 0 in frequency domain. Similarly, if you find the area in frequency domain in terms of f, you can find the area in terms of f or in terms of omega also. If you find the area in frequency domain in terms of f, then it is same as value at 0 in time domain. Value at 0 in time domain is equal to area in frequency domain. Value at 0 in frequency domain is equal to area in time. I hope you are observing the dual nature here. If you are finding the area in time domain, it is equal to value at 0 in frequency domain. Similarly, if you find the area in frequency domain, it is same as value at 0 in time domain. Okay, we'll take some problems and we'll understand it better as we go further. Right. So similarly, if you are finding the area in frequency domain in terms of omega, if you are using integration as with respect to variable omega, then you have to use the 2 pi factor extra, 1 by 2 pi factor extra, and then only that value, after using that 1 by 2 pi factor, then only it is equal to value at 0 in time domain. Always whenever you are doing integration with respect to omega, keep in mind that there should be a factor of 1 by 2 pi. Okay, even in the inverse Fourier transform formula also it is there, and from that for inverse Fourier transform formula only we got this property. We also call this as area property. We also call this as area property of Fourier transform. Area property of Fourier transform. And whatever observation we have done here, similar observation you can make in every transform. In every transform you can make similar observation. Take the formulas, substitute variable with 0, substitute variable with 0 in transform and inverse transform. You'll be observing some beautiful things. And questions will be based, generally will be framed based on these basic observations. Even if you forgot these things also, no problem. If you know the formulas from them, just substitute the variable with 0 and then you'll be able to get this area property. Very simple but very powerful. Okay. Hi Ankit. Fine, I hope it is clear till this point. Anybody is having any doubts? Anyone wants me to explain once again anything? If you want me to explain anything once again, just let me know. Fine, Ankit, I hope you are following. Fine. So can I assume that you have understood clearly till this point? If you have understood without any confusion, I'll ask you a question now. We'll solve some problems based on this basic. Fine then. So I'm going ahead. If there is any confusion in between also, you can ask me. Right. Okay. Fine. Fourier transform of a signal x of t is given as shown in the figure. As shown in the figure. Okay. So before giving the question, I just want to tell you one more property here. So that property is very close to whatever properties we have discussed here. So that's why I want to tell that property here itself. So, and so that we can, in the next problem that we are going to do, I'll involve this property that I'm going to discuss next. So it is Raleigh's energy theorem, we call it. We call it as Raleigh's energy theorem. So as the name says, it involves energy. I hope everybody knows how to find energy, right? We know how to find energy using time domain signal. But using this theorem, we can find energy using frequency signal also, frequency domain signal or Fourier transform also. As we have discussed, this time domain signal x of t or its corresponding Fourier transform x of omega, they both represent same information, right? One represents information in time as independent variable as time, and another represents information as a function of frequency. But both consist of same information, right? So can we find the energy in time domain? So if you find the energy in time domain, how do you find the energy in time domain? Square the signal and just integrate it. If you square the signal and integrate it, that is going to give us the energy of the signal x of t. This is going to give us energy of the signal x of t. Okay, and what Raleigh's energy theorem says is, whatever energy you are finding using the time domain signal, it is same as the energy you find using the frequency domain signal also. So how do you find the energy? Basically squaring it and integrating it. That's it, right? Square the signal and integrate it. So if you take the Fourier transform, square it and then integrate it. Since omega is involved here, whenever integration is with respect to omega, there should be a factor of 1 by 2 pi. And same formula in terms of f, if you write, there is no need of 1 by 2 pi factor. And squaring x of f, integrate with respect to f, limits from minus infinity to plus infinity without 1 by 2 pi. So this is what is this? This is energy of x of omega divided by 2 pi. If you find the energy of x of omega and then divide it with 2 pi, it is same as the energy calculation for x of t. Since x of t and x of omega represent the same information, so that's why if you calculate the energy of the signal in time domain or in frequency domain, they are same. So when you are dealing in terms of omega, there is a 1 by 2 pi factor extra, or this is also same as energy of x of f. These three are same. That is what is the statement of Raleigh's energy theorem. So calculate the energy in time domain or in frequency domain, it is same. But if you are calculating the energy in frequency domain as a function of omega, as integration with integration variable as omega, then you have to make sure that there is a factor of 1 by 2 pi. Okay, right. So I hope you are clear with this theorem, Raleigh's energy theorem. So the name is so big as if it is some tough theorem, but it's not really tough. It's simple basic only. So we call it as one property of Fourier transform. So why I'm discussing here is, so this is very easy to understand in link with this, and we can solve the problems based on this Raleigh's energy theorem also. We can complete the problem solving based on this property also right now. Yeah, Neha, you're asking something. 1 by 2 pi factor should be squared as x of omega squared. No need. Not required actually. See this one? It is d omega, right? See this one? It's d omega. D omega, if you replace it with 2 pi f, then what happens? It becomes 2 pi into df. That 2 pi and 2 pi cancelled, it will become df. Right? So signal is squared. Why is it squared? Because you want to find the energy, no? The signal x of omega is squared and then integrated with respect to omega. Whenever we are integrating with respect to omega, then we use the factor 1 by 2 pi. Okay, so 1 by 2 pi need not be squared. Only the signal is squared and then integrated with respect to d omega. Okay, right, very good. So now we have discussed three things. One or else two things specifically: area property and Rayleigh's energy theorem. Inside area property, there are internally two properties: area in time domain property, area in frequency domain property. So area in time domain, area in frequency domain, energy in time domain, energy in frequency domain. We know the relations between them. Right. Now let me give you the question. Hi Sindhuja, welcome to the class. Any doubts you can ask me. Don't hesitate to ask any doubt. Right. Fourier transform signal x of t is given. So I have given you the Fourier transform, right? Yeah. Right. So this is the given data. Now let me ask you the questions. Find x of t equal to 0. Second question. Second question. First, can you try these three questions? And then I'll increase the trickiness a little bit more after these three questions. Anyone? X of t equal to 0. But you don't know x of t. If you know x of t, understanding the value at t equal to 0 is easy. But x of t is not given. Its Fourier transform is given. Fourier transform of a signal x of t is given. And I'm asking you the signal x of t's value at t equal to 0. Okay. So how do you find the value at t equal to value at 0 in one domain? We can use the property, right? Area property. What is area property? At t equal to 0, if you want to find the value, it is same as area in frequency domain. Area in frequency domain. If you're dealing in terms of f, just simply area. If you're dealing in terms of omega, first find the area and then divide it with 2 pi. That is also there. Okay. So x of t equal to 0, if you want to find using x of omega, yes, we can do that. And how do we do that? It is integration from minus infinity to plus infinity, x of omega d omega 1 by 2 pi. If at all, if you forgot this, no problem. First recollect the formula in Fourier transform formula and inverse Fourier transform formula. So in the inverse Fourier transform formula, you want t equal to 0, x of t equal to 0, right? So put t equal to 0 on the other side also. You'll get the required thing. Okay, simple stuff. Just have the confidence and do it. Parth Sharma, it is not in GATE CS and IT syllabus. But this might be part of your mathematics. If you're having Fourier transform as part of your mathematics, then this might help you a little bit. Right, 1 by 2 pi integration x of omega d omega. So integration means it's area, right? It's just simply area. 1 by 2 pi times area of x of omega. Area of x of omega. Don't do the integration, because if you want to do integration, yes, we can do it. First, you have to write the equation of it, and then you have to do the integration. But actually, it is not required, because integration means area, and we can find the area of this graph very easily. So whenever your straight lines are involved in the graph, find the area directly using our 10th class or 9th class basics, using as area of rectangle, area of triangle. But if it is a complicated graph, then only use the equation of the graph and substitute in the inside the integration and then integrate it. If it is some kind of x square or x cube kind of graph, then substitute the equation and then integrate. But this is a simple graph, right? You can go ahead with integration, or you can do it directly. You can find the area directly also. And what is the area? The area of the, just look at it as a rectangle and a triangle separately. The area of this rectangle part is 4 is the width of the rectangle and 4 is the height of the rectangle. So 4 4 is 16 is the area of this rectangle. And what is the area of this triangle part? Half into base into height. Half into base is 2 units and height is 4 units. 2 cancelled. How much is that? It is 1 by 2 pi into 4 4 is 16 plus 4 is 20. So if you cancel that 2, it becomes 10 divided by pi. That is the answer. Okay. Neha, very good. Very good. So can you solve the next question also? I hope everybody has understood the first one. If there is any confusion in the first one, you can just let me know. So now let us start the second one. So squaring is happening. Signal is squared and then integrated. What does it mean? They are asking us to find energy of the signal x of t. Energy of x of t. Yes, we know how to find energy of x of t if you know x of t. But x of t is not given in the problem. X of t is not there in the problem. But x of omega is there. So is there any way in which we can find energy of x of t without knowing x of t but by using x of omega? Yes, we can find it if we can use the property that we have discussed previously. And that is Raleigh's energy theorem. By using Raleigh's energy theorem, we can find it. So area in time domain, energy in time domain is same as energy in frequency domain. So we can use this formula or this formula. So since the Fourier transform is given in terms of omega, we're going to use this formula. Right. So let's do it. So energy in time domain is same as energy in frequency domain. Integration mod x of omega whole square d omega. When are we going to use mod x of f whole square df? When the Fourier transform is given in terms of f, if the variable here is f, then we are going to use the formula in terms of f. So based on what variable they are giving the Fourier transform, based on that you are going to use the formula accordingly. Right. So this is the formula. Whenever you are dealing in terms of omega, there is a 1 by 2 pi factor. So this is 1 by 2 pi into 1 by 2 pi into, what is the integration of square root of this signal? Square root of this signal. If you want the area of square root of this signal, this part is easy actually. Okay, let me plot the squared version of this. If you square it, 4 square becomes 16. From minus 2 to plus 2, it becomes, the height becomes 16. And after that, so basically this is a linear graph, or it's like minus ax kind of graph, right? Minus ax plus b kind of graph. If you square it, it becomes kind of parabolic. So it becomes kind of parabolic. So graph will be looking something like this. And this is 4 units as a function of omega. So what we have here is x of omega whole square, mod x of omega whole square. So we can find the area directly. Though parabolic graph is involved, we can find the area directly, or you can go with the basic integration stuff also. Both ways we can do the problem. So let me do it in both ways. I'll do it in both ways. So if there is a parabolic graph, let me tell you this. If there is a parabolic graph, how to find the answer easily? if there is a parabolic graph, increasing parabolic graph or a decreasing parabolic graph like this, if there is a parabolic graph something like this, a decreasing or increasing parabolic graph like this, something like this, then what you should do is, if it's a parabolic graph, so something like y equal to x square kind of graph, y equal to x square kind of graph, or if it is in terms of t, some kind of x of t equal to some at square plus b kind of graph. So x of t equal to some at square plus b kind of graph. Okay, at square plus bt plus c also, anything is fine. So second order equation you can say. Whenever this kind of graph is given, if you know the width, let me say the width is some capital A, and the height of this one is some capital B, then area of parabolic graph, area of parabolic graph in the region from the starting point to ending point is 1 by 3 times base into height. Similar formula to triangle formula, but this is not a triangle, right? This is a parabolic graph. So for a triangle it is half into base into height. So for a parabolic it is 1 by 3 into base into height, you can say. Okay, base into maximum height, you can say. Okay, you can use this basic in the previous problem also. So let us use that basic. If you use that basic, the area of this rectangle part, we want to find the area of mod x of omega whole square. I have plotted mod x of omega whole square. Area of this graph is, width is 4 units and height is 16 units plus, what is the area of this parabolic graph? Parabolic graph is 1 by 3 times, base is how much? What is the base width of this parabolic part? 2 units, and height is how much? 16 units, right? So this will become 16 4s are 64, and this becomes 16 2s are 32 divided by 3. So it is 1 by 2 pi into 64 into 3 plus 16 2s are 32 divided by 3, which is 64 into 3. Is it 32 into 6 plus 1 is 7. 32 into 7 is like 7 2s are 14, 7 3 is 21, 22 224 divided by 3 into 2 pi. 3 1s, 3 7s are 21. No, it's not cancelling with 3. Anyone? Any answer? 16 4s are 64 plus 1 by 3 into 2 into 16, 32 by 3. Okay, 224 is correct. Okay, so it is 112 divided by 3 pi. Yeah. So we can write it like this, 112 divided by 3 pi. You can just leave it like this. If you want, you can simplify it further, but we can leave it like that. Yes, that should be correct only, Neha. 37.8. Yeah, that should be correct only. So 3 1s, 3 3s, 22 is 37.10. It's 37.8. Okay, 22. 22 if you cancel with 3, 3 7s, 1, 3 3s are 9. 3 3s are 9. 37.33, I guess. Yeah, correct, Arun Kumar. Very good. You can do it like this, or the other way of doing it is, so let me tell you the other way of, the very basic way of doing it. This is the actual procedure. If you are confused in any problem how to find the area, this is the procedure that you should follow. As a function of omega, mod x of omega whole square. Okay, So what we want to find is integration of mod x of omega whole square d omega limits from minus infinity to plus infinity 1 by 2 pi. This is what we want to find. Okay, right. So first of all, what you should do is you should write the equation for x of omega. So the basic way of integration is first write the equation for x of omega, and the equation is equal to 4. The equation is 4 from minus 2 to plus 2. Minus 2 less than omega less than 2. For the region between minus 2 to plus 2, for the region between minus 2 to plus 2, the equation is 4. And what is the equation from 2 to 4? Anyone? 2 less than omega less than 4. It's a straight line, decreasing straight line, which means it is having some negative slope. So the equation of this line will be of the form mx plus y equal to mx plus c, right? In place of y we are having x of omega. In place of x we are having omega. In place of x, omega. It's like m omega plus c. So can you tell me what is the slope of this line? In 2 units, it has decreased by 2 units. So slope should be minus 2 units. Everybody knows different ways of calculating slopes. You can calculate in your own way. So in my way, if I calculate the slope in this right angle triangle, if you can find tan theta, in any manner you can find the slope. So the slope is minus 2 units, correct? Minus 2 omega plus, what is the y-intercept? You can find the y-intercept in multiple ways. So if you extend this graph, wherever it meets y-axis, that is what is y-intercept. So if you extend it, it intersects at 8 units. Or there are other techniques also to find y-intercept. You can do it in your own way. And for the remaining values of omega, the equation is 0. So let me write it as else. What I mean by else is omega greater than 4 or omega less than minus 2. Omega less than minus 2, omega greater than 4, the equation is 0. So keep this equation in mind. Now, what is the equation of x of omega whole square? X of omega whole square equation is minus 2 less than omega less than 2 and 0 less than, 2 less than omega less than 4 and elsewhere. In 3 regions, we have written 3 different equations, right? So let us copy the same equations but by squaring, because we want square of that equation. So it is equal to 4 square and minus 2 omega plus 8 is the equation for x of omega in this region. So we want square of it, so square it, just square it. And 0 here, 0 square is 0 only. Okay, wonderful. Right, so we got x of omega whole square equation. Now let us substitute in the integration. So what I'll do is, we have to separate the integration into different parts. In maths, you might be using direct formulas. Here also we are going to use the same thing, but limits, equation of slope, you want me to explain, Arun? Yeah, sure, I'll explain that. Let me complete this part. Okay, right. Minus infinity to minus 2, we know the equation, right? So that's why we are separating the limits into different regions. And then minus 2 to plus 2 I'm separating. And then 2 to 4 also I'm separating, because 2 to 4 it is having a different equation. In whatever region it is having different equation. So separate the integration limits into different parts. And last part is 4 to infinity. Okay. So why I'm separating like this? Because it has different equations in different regions. So else, instead of else, if I write instead of else, that will be more clear for you. Why am I separating the limits of integration in this manner? It is 0 for omega less than minus 2 and it is 0 for omega greater than 4. Omega greater than 4. Okay. Right. So for omega less than minus 2 means it's from minus infinity to minus 2. What is the equation? 0 d omega. And minus 2 to plus 2, we have a different equation which is 4 square. 4 square means 16 d omega. And in the limits from 2 to 4, it has a different equation which is minus 2 omega plus 8 whole square d omega. Next, from 4 to infinity, for omega greater than 4 means 4 to infinity, the equation is what? 0 d omega. Now you can do the integration. It is 1 by 2 pi. So this part becomes 0. And what is the integration of this part? 16 integration is 16 omega. Limits are from minus 2 to plus 2. Plus integration of this part is minus 2 omega plus 8 whole cube divided by 3 into differentiation of the inside part is minus 2. I'm just doing simple integration here. It's some kind of ax plus b whole square integration is ax plus b whole cube divided by 3 into differentiation of the inside part in the denominator. And limits are from 2 to 4. Next part, integration of 0 is 0. So it is 1 by 2 pi into 16 substituted with the 2 and minus 2, it becomes 2 minus of minus 2, which is 4 units, plus this will become it is 1 divided by minus 6, 1 divided by minus 6, I'm putting it outside, and if you substitute 4 inside, upper limit if you substitute, it becomes 4 2s are 8, minus 8, 4 if you substitute here, it's minus 8 plus 8 becomes 0, minus, let us substitute the lower limit also, 2 if you substitute here, it becomes minus 2 into plus 2 is minus 4, minus 4 plus 8 is plus 4 cube divided by, that's it, minus 6 is outside, no? Yes, that's it. So which is equal to 1 by 2 pi into 16 into 2 minus of minus 2 is 4, 16 4 is 64, and this minus and minus it becomes plus, 4 cube is 64 divided by 6. Okay, it is equal to 1 by 2 pi times 64 into 1 plus 1 by 6, which should be same as the answer that we got previously, 64 into 7 by 6, 2 ones, 2 32s, and roughly same answer you should be getting, 37.33, 32 into 7 by 6 if you calculate, it should be roughly 6 ones, 6 5s are 30, approximately little more than 5 here. So little more than 5 multiplied with 7, 7 5s are 35, it should be little more than 35. So if you calculate, it should be exactly speaking 37.33 divided by pi. So that is what we got previously also. So this is the basic procedure. But if parabolic signal is involved, as I told you the formula previously, okay, understand the width of the parabolic graph and height of the parabolic graph, maximum height of the parabolic graph, and use this formula 1 by 3 into a into b. That will give you the answer very easily. This is the easiest way to do. Okay, if you're going with integration procedure, yes, this also we can solve it fastly, provided you are really good with integrations, and you should be really good with integrations. Otherwise, cracking GATE exam is not so easy. So you should be really good with integrations and differentiations, because that is the basic thing, right? And integrations and differentiations will help you to understand any subject, not just mathematics. Fine, I hope it is clear till this point. Right, now coming to Arun has asked me something. Let me tell you how to find the slope, how to find the equation of a signal. Fine, let me use different variables so for your understanding sake, because you are always used to x and y, x on x-axis, y on y-axis, right? So what I'll do is I'll use y on y-axis and I'll use f of y on y-axis. Okay, now let me show you. Right, so this is the graph that I've given you. Can you tell me what is the equation of this graph? Sometimes it requires us to write the equations, sometimes, not every time, but we should be good with writing the equation, and from the equation you should be able to plot the graph also really quickly. How can can you tell me how to do that? So same concept, y equal to mx plus c. In place of y we are having f of y. Y equal to mx plus c is mathematics, where x is taken on x-axis, y is taken on y-axis. But here I've changed the variables. On y-axis we are having y. On x-axis we are having y. So in place of x have y, and in place of y have f of y. Okay, so based on the variables in the graph you have to adapt accordingly. So don't blindly take y equal to mx plus c only always. Y equal to mx plus c will change according to the variables involved. In place of x we are having y here, that's why I'm taking y here. In place of y we are having f of y. Okay, right, so tell me this. So slope, so if you take it as a right angle triangle, if you just imagine it as right angle triangle, what is slope here? Slope is tan theta, or you can say opposite side divided by adjacent side. And what is the opposite side here? 6 units length, and adjacent side is of 3 units. That is the easiest way to find the slope. 6 by 3 into y. Or slope, I would say, I would define it as a rate of change of amplitude. A rate of change of amplitude, or let me define it in another way. Change in y axis for 1 unit change in x axis. For 1 unit change in x axis. This way also we can find. So see here, what is happening in 3 units. Within 3 units of time, 3 units of y axis, for 3 units change in x axis, what is happening with y axis? 6 units is changing. For 3 units change in x axis, 6 units is changing. Means if there is a 1 unit change in x axis, what is the change in y axis? For 1 unit change in x axis, what is the change in y axis? That will give you the slope. For 1 unit change, there should be, divide with 3 on both sides, there should be a 2 unit change. So for 1 unit change on x axis, whatever is the change in y axis, that itself is the slope, which you can understand it directly. That is how I calculate the slope. I don't use the standard of hormone and all that. I just generally look at this way. Okay, in 3 units, it has increased by 6 units, which means within 1 unit, how much it will increase? That itself is the slope. Next, similarly, 3 to 5, what is happening? In 3 to 5, in 2 units, what is happening to the amplitude? From 6, it has gone to 0. How much is the change? Change means always final minus initial. What is the final value? 0. Initial value is 6. So change is what? Minus 6 units. Within 2 units, for 2 units change on x-axis, there is a change of minus 6 units. Don't say 6 units because it has decreased. Change is negative when it is decreasing. Change is positive when it is increasing. So for 1 unit change in x-axis, what happens with y-axis? Divide both sides with 2, minus 3 units. So for 1 unit change in x-axis in this region, for 1 unit change, what is happening? Minus 3 units is changing, which means there is a decrease of 3 units. Very simple to understand slope in this manner. Or by using a right angle triangle concept also, you can find the slope. So any manner that you have learned in mathematics is fine. If you don't have any procedure in particular, you can use my procedure. Right. So the equation is f of y is equal to, use that basic here. And what is this equation? 6 by 3 is the slope in the region from 0 to 3. 0 less than y less than 3. Similarly, for 3 to 5, 3 less than y less than 5, what is the equation? Slope is minus 3. In place of m, minus 3 into y plus c. And here, c here and c here need not be seen. Okay. But first case, 0 to 3. It's a straight line passing through origin. Whenever a straight line passes through origin, it is intersecting y-axis at y equal to 0. Okay, at whatever point it intersects y-axis, that itself is the y-intercept c, which is in this case, it is 0. Because this line from 0 to 3, it is passing through origin. Whenever a line is passing through origin, y-intercept is 0. Next, for 3 to 5, this is a line only restricted from 3 to 5. But if you extend it, wherever it meets x-axis, wherever it meets y-axis, that point is what we call as y-intercept. So if you can imagine where it can intersect it on y-axis, that way you can find c. That is one way. Can you imagine how it can intersect? When you go from 5 to 3, it has increased by 6 units, which means within 1 unit, when you are going from 5 to 1, for 1 unit it is going to change by 3 units. For 5 units, it is going to change by 5 3 is 15 units. So it is going to intersect here at 15. So y-intersect, c is y-intercept, which means the point where it intersects y-axis. So you see, you can substitute it with 15. That is one way, but this might not be so easy for everyone. So if you can imagine this way, that is fine. Or else what you can do is 3 to 5 equation we know, right? At 3, what is the equation? Or at 5, you know the value, right? The value of f of y, equal to 5. F of y at 5 is 0, right? Now, the equation from 3 to 5 is minus 3y plus c. Minus 3y plus c is 0. So if you want at y equal to 5 the equation to be 0, how much should be c value? You can find, no? So minus 3y is equal to minus c, minus cancelled. 1 second. Yeah, minus 3y plus c equation should become 0 when you substitute y equal to 5. When you substitute y equal to 5. So let me substitute y equal to 5 here. The equation at y equal to 5, the valid equation at y equal to 5 is this equation. Minus 3y plus c should be equal to 0. In place of y, replace it with 5 to make it 0. Only at 5 it becomes 0. So minus 5 3 is 15 plus c is equal to 0. C equal to 15. So this is one way of finding the y-intercept. So c you can replace it with 15. So I believe everybody got the same answers, right? So 6 by 3 I'll replace it with 2. Arun, I hope you are following. So this is how you are gonna find the slopes. So let them give any variable on x-axis and any variable on y-axis. It doesn't matter. Same procedure. So same way you can try to write the equation here also. So 2 to 4 within 2 units on y. For 2 units change on x-axis, there is a change of minus 4 units on y-axis. For 2 units change on x-axis, there is a change of minus 4 units on y-axis. Which means for 1 unit change on x-axis, there is a change of minus 2 units. So that's why the slope is minus 2. So if you extend this, it will make x-axis, y-axis on at 8 units. That's why y equal to mx plus c, m is minus 2 and c is 8. It's the same procedure. Right. So can anyone answer the next question now? Third question. Can you answer the third question? The third question. Integration of x of t dt. How to find the area of the signal x of t without knowing x of t. Can you do it? Without knowing x of t, how can we find the area of x of t? Yes, we can find using area property. Can we find area of x of t without knowing x of t? We can use this relation, right? Area of x of t is same as value at 0 in frequency domain. So if you don't know x of t also no problem. If you know Fourier transform, from Fourier transform, if you observe the value at f equal to 0, that value is same as area of the signal in time domain, right? So that's the basic here. See, the question which looks like not able to solve is becoming a very easy question using the area property. So this is same as x of omega equal to 0 or x of f equal to 0. X of omega equal to 0 or x of f equal to 0, both are exactly same. So it's a very simple question, right? What is the value of x of omega at 0? At omega equal to 0, the value is 4 units. So area of the signal in time domain is just 4 units. Very simple question, right? Fine. I hope this is clear. It is clear till this point. Wonderful. If you are having any questions, you can ask. Till this point, I believe there is no questions. If there is any further questions, any doubts, you can ask. Okay. Shall I give you a homework also? Shall I give you a homework as well? Let me give you a homework also. So same question, same 3 questions. I believe you have copied this part. The same questions. Fourier transform of a signal x of t is given as shown in the figure. First question, second question, third question. Same questions exactly, whatever I have written in red, same questions. But I am changing the graph of x of omega. That is the only change. Everything else is same. Okay. I am changing the graph of x of omega. All the remaining 3 questions are exactly same. Okay, so this is the graph. I have given you the graph as a function of f. You have to mind this. Previous graph was given as a function of omega. Now I'm giving you the graph as a function of f. Now the question is, same questions previously, whatever I've asked you, I'm just writing them again. Find x of t equal to 0. Find integration of mod x of t whole square dt, limits from minus infinity to plus infinity. Right. So for this graph, for this Fourier transform, using this Fourier transform, try to find these three values. This is going to be your homework for today. So tomorrow we'll observe and we'll try to do more problems based on the same concept, and we'll try to learn something more into tomorrow's class. So tomorrow also we're going to meet at the same time, 9 p.m. So if possible, try to join the class on time. So it will be more helpful for you. Right. So have you copied this one? If you have copied this part, take a snapshot if it is taking time for you to copy. Okay, right. So give me a few minutes. So if anybody is not in my Telegram group, I'll share my Telegram group details as well. You can join yourself to that group. It's a private group. Anybody can join, and any questions that you have, you can post it in that group. So I'll share that. So before that, just let me give you some details about the Unacademy subscription and how you can attend my regular classes also if you are interested. Right. So basically, I teach two subjects for GATE exam. So signals and systems and communication systems. So the signals and systems subject is part of electrical students, electronics and communication students, as well as instrumentation students. Whereas communication subject is there for only for electronics and communication students and instrumentation students. So this communication system subject is there for electrical students also as part of ESE syllabus. So I'm good at these two subjects. So I teach these two subjects in a very comprehensive manner. Right. So this is my page on Unacademy. On Unacademy, you can just search with my name. In Telegram also, you can search with my name. You'll get my group details and my personal Telegram ID also. So just search with my name and follow me on this page so that you'll get updates on my classes. Whenever I take a special class, you'll be able to know about the special class. Right? Yeah. So right now my course that is running on Unacademy Plus platform is Random Variables and Random Process. It has been started already. You'll not be able to. Even if you start attending also, it will be in the middle. So, but if you want to attend, you can watch the recordings of this class, recordings of this course. It's a very detailed course I'm going to take here. So this is a tough course for electronics and communication students. So if you're interested to attend, you can take this. You have to take the subscription if you want to attend these classes. But whatever classes I've taken, they are all available in recorded format on Plus platform. So these are all the courses that I've taken in the last 1 year. So whatever subjects I'm good at, those subjects I have already taught multiple times. And I'll be teaching every 2 months. I'll be teaching the same subjects. And so, yeah. So these are the new batches that were started on Plus platform recently. So there is a batch called Ascend 2-year batch, which is meant for students who are targeting GATE 2022. So this is the team of faculty. You can see the faculty here. So the profiles are not given clearly because of the space constraint. Because multiple teachers in this list of teachers are IITians, including me, and some teachers are IES officers, and they have cracked IES with the 2-digit rank, and are single-digit rank also. Some people, and other teachers are really like 20 years or more than that experienced. So it's a combination of experience and IITians and IES rankers, all that. So one more batch is there for semester-going students, college-going students. If they want to learn semester subjects only, so they can attend this batch, or students who are looking for targeting 2021 only, but not started preparation much to a very good pace. Then this batch is for you. So it's a fast track course, which we'll cover the syllabus in a fast track manner, so that then only we can cover the complete syllabus maybe by December or January, because only 4 months is left for our exam. So if any student is targeting GATE 2021, you can think of attending this batch. But for attending all these batches or for attending many of my courses, regular courses, complete course if you want to attend, you have to take subscription. Only for Fourier Transform, you don't need to take any subscription. You can attend the free classes only. I'll be taking free classes every month, 10 to 15 classes I'll be taking. All those classes you can attend for free. But if you want to attend the subject from starting to ending, all the concepts, then it's better to take subscription. Okay. So if you are lagging only in that, but in particular concepts, and those concepts, if you are taking on special classes, there is no need of any subscription. But if you are in need of learning many concepts, then it's better to take subscription, right? So the fees for subscription is also very economical. So compared to offline coaching centers, the best offline coaching centers, if you see, their fees is around 70-80K. So compared to that, this is like hardly 1/3 of it. But the quality that we provide here is definitely much better than the best offline coaching centers also. And one more thing is, this subscription is like a Prime subscription, Amazon Prime subscription, or Netflix subscription. So there also we'll have 1 month, 3 month subscription, right? Here also same way. So you can take subscription for 1 or 3 or 6 months, similarly 24 months also. So based on your requirement, you can take the subscription for any number of months. So if you just want to try out the platform and see how good it is, then you can try a 1 month subscription and see if you like it, and you can extend the subscription. And if you are already good with your preparation, and if you're looking for few subjects to learn from us, then it's better to take just 3 month subscription. Or if you want to learn half of the subjects, then it's better to take 6 months. Or if you want to learn most of the subjects, then it's better to take 12 month subscription. And if you are a college going student, it's better to take a 24 month subscription, right? Right. So on top of this fees, this economical fees, you can note down this code. So if you wish to take a subscription at any future point of time, you can make use of this code. This is my referral code. Once you use that code, you'll be getting a further discount. So if you wish to take subscription, you can make use of this code. And coming to the last and most important part, this is my personal Telegram ID. So if you need any support from my side, maybe in terms of guidance or whatever you feel like asking me, if you think that I can help you with that, so you can message me on this Telegram ID. This is my personal ID. And if you're having any doubts, don't post to my personal ID. This is the group that I'm maintaining exclusively for doubts. A lot of hundreds of questions were already solved in the group. You can go through them if you want. And if you're having any new question, you can post it in the group. We can help you with those doubts. Okay. So this group, just search with my name. So as soon as you search with my name, you'll be getting the group also. The name of the group will be Signals and Systems. Signals and Communications, because the group is meant for solving questions, solving doubts on signals and communications, only those 2 subjects. Okay. And if you're having doubts in other subjects, we are maintaining another group. Me along with other teachers, 3-4 teachers together, we are running another group where if you are having any doubts in other subjects, you can post it in the other group. Okay, fine, you can add yourself to that group. So this is a private group only, so this is a public group, so you can add yourself. Okay, so that's it from my side. So thank you. Fine then, have a good night. We'll meet tomorrow, same time.